Hi guys, welcome back. So in this video, I want to briefly talk about the idea of a definite integral and how can one evaluate or calculate a definite integral of any function, okay? So guys, in simple words, definite integral basically helps us to find out the area under a curve. It's as simple as that. So there are other ways of evaluating area under the curves, but one of the most useful ways is to actually use the definite integral. So for example, if we have a smooth continuous curve and let us say we call it f of x and we want to even if it goes it goes on forever for both directions, but we are only interested in finding the area under this curve. So let us say we are only interested between points a and b. So a being my lower limit, we can think of a as a lower limit and b as a high upper limit, and then we're interested in finding the area under this curve. So to find the area under this curve, obviously there's other ways of doing it. One of the very efficient ways is to calculate the definite integral, and the notation for that is, we already know the notation for the integrals, so it is just basically the notation for the integrals, but we only add the lower limit and the upper limit. So the definite integral, which gives us the area under this curve, is something like this. It goes from a to b, and then this is f of x with respect to dx. Guys, as I have already mentioned this in my previous videos as well, about when we introduced the idea of an integral. So you can think of this as a length and the other one as a width. So it's like just adding up all the, basically what we try to do is we just try to break this down into so many small rectangles, and we try to evaluate the areas of each particular rectangle, and then we finally add them. And this process basically, like, inside this integral, that is what is happening actually behind the scenes, okay? So that helps us to evaluate the area under a curve. That's one of the main purposes of evaluating or using the definite integrals. Now, to evaluate a function like this, what we have to use is called the fundamental theorem of calculus. So guys, here I'm not trying to verify or prove the fundamental theorem of calculus. I'm just going to write it out. So I'm going to basically write the formal way of writing it, and that actually helps us to evaluate these definite integrals, okay? So I'm going to write it, I'm going to show you how it helps us to evaluate the definite integrals, and then we'll have examples where we apply that fundamental theorem of calculus to evaluate definite integrals, okay? So this is what the fundamental theorem of calculus says. Sometimes people also like to use the short form for fundamental theorem of calculus. People like to use the short form FTC, okay? So this theorem basically says if we are working with a continuous function, if f is a continuous function, so something which looks like this, which there's no discontinuities, it's a nice function, and which is defined in on the interval. In this case, we are doing it for this from a to b, okay, which is defined on this interval. And then if we have this uppercase f, which is any antiderivative. So this uppercase f is the antiderivative. It says any because we know that there could be more than one because of that plus c thing. So it's any antiderivative of this original function f. Of course, it's going to be of that function f, and it also has to be defined and is defined on this interval a to b. So both have to be defined on this interval that we are interested in, which is like as our lower limit and the upper limit. Then we have, so this is what the fundamental theorem of calculus tells us. It says to evaluate an integral, a definite integral from a to b f of x dx, that is equivalent to evaluating the antiderivative of this function f of x at the upper limit, which is b in this case, and then minus the antiderivative of this function f of x at the lower limit. That is what the fundamental theorem of calculus actually tells us. Guys, this is not so difficult to understand, and it's not so difficult either to apply to evaluating definite integrals. Basically what it says that to evaluate a definite integral, all you have to do is, first you have to make sure that it is defined and it is continuous on this given interval, and a and b would be different for different examples. then what one has to do is one has to evaluate the antiderivative or the integral of that function, and we already know how to do that. We may have to use some rules, we may have to use sometimes substitution methods or the shortcut methods. And then once we have the antiderivatives, then we evaluate that antiderivative at the upper limit, which in this case is b, and then we also evaluate that antiderivative at this lower limit a, and we take the difference of those two values. That gives us the derivative, so the integral of that function, which is between 2 points between a and b. Okay, guys, that is what the fundamental theorem of calculus says. I would encourage you guys to actually go back and look at your textbooks and see the formal proof of this theorem. It is very interesting to see that as well. But guys, here I'm not really showing you the whole proof. All I want right now is to for you to see how the fundamental theorem of calculus works, and then I'm going to show you how this is applied to actual examples. Okay, so guys, take a note of this, and then I will see you in the next video with with some examples where we actually use this fundamental theorem of calculus.